Here's the question 1 of homework. Uh, from this question, we should do the two things. One is prove this function through A and B are independent. The last thing is prove A and B are independent through this function. Now let's uh, begin the first things. Prove this function through A and B are independent. Here's the definition of conditional probability, and we know that the probability A assuming B naught equals the probability A B naught over the probability B naught, and probability A naught assuming B equals the probability A naught B over the probability B. Because A, B are independent, A, B naught are independent. Also, A naught B are independent. Then we can get the probability A, B naught equals the probability A times the probability B naught. Also, the probability A naught B equals the probability A naught times the probability B. And through the above function, we can get the probability A assuming B naught equal the probability A B naught over the probability B naught, and the probability A B naught equals the probability A times the probability B naught. And the probability B naught and probability B naught cancel, so we can get the probability A assuming B naught equals the probability A. And at the same way, we can prove that the probability A naught assuming B equals the probability A naught. And then we take the probability A assuming B naught plus the probability A naught assuming B, then equal the probability A and plus the probability A naught and equal 1. Then we prove the if A and B are independent, and the probability A assuming B naught plus the probability A naught assuming B equal 1. We can finish the first thing, and then we begin the second thing. That is prove the A and B are independent through this function. And now let's begin the second thing. At the beginning, we should know that the probability B equals the probability Bs, and S equals A plus A naught, and through the distribution, we can get the probability B equals the probability AB plus the probability A naught B. And through this function, and we can get the probability AB equal the probability B minus the probability A naught B. And probability A naught B, we can, through the conditional probability, get the probability A naught B equal the probability A naught assuming B times the probability B. And they have the same probability of B. So we can take this together and get the function 1 minus the probability A naught assuming B. And from the condition, the probability A assuming B naught plus the probability A naught assuming B equal 1, we can get this from this. We can get this from this function, and then we should take the probability B to the left side, and we can get the probability A assuming B equals the probability A assuming B not. And then probability A equal the probability AB plus the probability AB not. This function can be proved by the probability B equal the probability AB plus the probability A not B. Then the probability AB from the conditional probability, we can know that the probability AB equal the probability A assuming B times the probability B, and the probability A B not equals the probability A assuming B not times the probability B not, and the probability A assuming B equals the probability A assuming B not, so they can together turn out to be the probability A assuming B and the probability B plus the probability B not together, and this one can turn out to be 1, so the probability A equal the probability B A assuming B. And then we can get the probability AB equals the probability A assuming B times the probability B, and the probability A equal the probability A assuming B, so A equals the probability A, so we can get the probability AB equals the probability A and times the probability B, so we can get the AB are independent. That is the second thing improvement. Thank you.